Welcome everyone from me as well to the GP4L Infoshare. We will talk about the global platform for labs, which is GP4L. I will start with a very short introduction on what is GP4L, what it offers, what are the objectives, what are the users and the opportunities, how you can use GP4L for different types of experiments or other types of use cases. And then we will go into more details of what exactly you are able to use, how you can do it with other presentations. And then we'll also talk about a few use cases of how we already use GP4L for different objectives, which might inspire you on other ideas of how you can take advantage of what the GÉANT project has to offer you. So first of all, when we say global platform for labs or GP4L, what do we mean? In the previous phase of the project, we tried to develop a sort of an ecosystem, so a complete environment where you can experiment, where you can innovate, or you can collaborate with the team and with others on different types of topics that involve network programmability or any type of new networking practices. For the part of the network programmability, we use the first so-called pillar of the global platform for labs, which is a P4 testbed. So this is a real hardware infrastructure that has been procured by the GÉANT project and is available for use by you. Also connected to other similar P4 devices across the world. So it creates a really global environment for testing and implementing different types of protocols using network programmability. On top of it, in order to create this ecosystem, we added the so-called labs. This is a software layer, software environment on top of the testbed, where you can use readily available network management containers in order to manage the testbed and develop different types of networking practices, or you can develop your own software and your own applications that can be added to this ecosystem and then test how it works in the isolated environment of the testbed. Of course, for these two things, we have a full team that is part of work package 6, task 2, that is developing using the P4 testbed and developing different solutions around it. So we have a community where you can join, ask for expert opinion, ask for help, discuss, share ideas, and so on, so that you can take the full advantage of what the global platform for labs has to offer. In the bottom of this slide, on this link, you will find the full documentation of GP4L, what it is, what it has, how it can be used, and different types of examples for the already developed labs. The objective of GP4L is to actually provide its users with access to these experimental facilities. When we say experimental facilities, we mean both things. So the hardware, the testbeds that you can use, and also the software on top. So the playground or the sandbox where you can use different types of applications. The idea is that in this isolated environment, you are free to test any type of solution that you have developed in a safe environment, isolated environment, not in your production network. So you can see how it reacts, what needs optimizing, and so on. One of the benefits is that all of these devices are geographically distributed. So you can really do different types of experiments by using different types of devices that are intentionally close to each other or intentionally far away from each other. The other thing is that the bandwidth that connects these devices is quite high in various. Frédéric will tell you more about it. So it helps you really develop these data transfer experiments with high speeds up to 4 gigabytes per second. In this way, you can use GP4L to test and validate any type of solution or new idea or new protocol that you have developed. Or you can also work with the team of experts and together with their help, co-create different types of solutions. So all you have to do is contact us and tell us what you would like to do, and we will try to do our best to help you on this journey and give you the support you need. Who are the GP4L users? basically anyone that would like to use the GP4L environment. First of all, for GÉANT, these are the network engineers and management, the net DevOps teams from different NRENs or affiliated research and educational organizations. But it can actually be a different type of research team, or research organization, or even a research individual that has an idea, would like to test out something that can get access to the testbed and to the software applications and use GP4L in order to obtain answers to their questions and improve their research. The way the environment is developed, it provides you with a lot of opportunities. So you can do this type of real world network experimentation because the testbed itself, it's real hardware that is deployed in the network, connected with real links and everything, as I said before, geographically distributed. So it provides you with a lot of opportunities to create different types of real world network experiments and get the results. It's also an isolated test environment. So it is safe to innovate, to test out, to see what happens. You're not going to break any production network if something goes wrong or something like that. So it's quite safe. It's quite easy to play and to develop different new things inside it. The idea is to basically in this way help you evolve your network operations, evolve the network by implementing new network solutions on top, or maybe making your network more programmable. Anyhow, all of these things can be done together with the team that sits behind GP4L, so you can work together in a sort of a community and create a collaborative environment where you get help and support for what you would like to do. The last example of values that are provided by GP4L are, of course, educational values. So you can also think of this environment as a way to educate other researchers, or maybe your students, or whoever is interested in network programmability, because it's isolated and safe to use. It's quite the place where you can actually test out network programmability or learn P4 in a way. As I mentioned before, GP4L has 3 components. So the experimental testbed, the GP4L playground that sits on top, and the community, the people behind it that can help you work through it all. So you can choose which of these components you would like to use. You can just use one, or you can use a combination of these components and create the environment that you would like to have in order to innovate research and do your experiments. For an example, Pioneer, the Polish NREN, is actually working with the community and taking advantage of the playground and the experimental testbed itself in order to develop an innovative solution for service provisioning for their services inside the NREN. The GP4L experimental testbed is quite interesting for use because it is, as I said before, geographically distributed and connected to other devices that are globally distributed across the world. That means that you can basically create a cutting-edge network experiment in a very large-scale programmable network infrastructure. So using the orange pins here, which are the GÉANT network devices, you can actually connect to the rest of the P4 devices in Europe and the Americas and Asias and so on, and create a very, very large network where you can test out whatever you want to do. The footprint of the GÉANT testbed itself, it's actually 9 nodes that are distributed across Europe. What you see on the right-hand side of this slide is the whole European footprint, which are the GÉANT nodes, together with other nodes hosted by the NRENs that are part of the GÉANT network. On top of these nodes, as I mentioned before, you can develop different types of labs. So some of the examples involve investigate new networking technologies, innovate network protocols, define new solutions for automation, orchestration, see what is the best way to implement, for an example, net DevOps principles in your network by using them in this playground. All of these software layers, which are on top of the hardware infrastructure of the testbed, are actually implemented using NMAS, which is another service provided by GÉANT. So by putting NMAS on top of the GP4L testbed, we actually create a virtual sandbox playground where you can develop different services and use them in your environment. What you can do inside this playground, well, it depends on you. So you can develop any type of automation, orchestration that you can think of. You can play with different types of sources of truth, implement different components that talk to each other via their APIs, test out using GitOps, for an example, do different types of verifications, including implementations such as a digital twin that we have worked a lot in the past, using different new implementations such as network visualization, where you create graphics as code, which is something of a use case that Frédéric will present you later. As I mentioned, our team is also using this playground to develop different types of use cases and solutions for the benefits of the work package, also for the benefits of different partners that reach out to us and would like to collaborate. All of these use cases and solutions are based on a few principles, which say that the solutions should be as much generalized as possible, as much modular as possible, so that they can be reused by others in our community. So if we are working on service provisioning together with Pioneer, we are thinking about service provisioning in any other and run inside the GÉANT community. So once the code is ready, it is published as open source code together with a full documentation. Anyone who is interested can come and take a look at the solution and decide to reuse the whole or just a piece of the solution. Service provisioning is just one example for which you can use GP4L. There are many others. What you see here on these slides are just some experiment use cases and examples for which GP4L has already been used. For an example, the very popular innovative source routing paradigm developed by R&P, which is called Polka, or routing and forwarding of site tags based on IPv6, which has been done by CERN. Very different types of use cases are usually being showcased during supercomputing conferences by different groups that are using different parts of the global GP4L experimental testbed. The development of digital twins for different organizations, many use cases involving network orchestration and automation, and as I mentioned also before, and what will be presented today, interactive visualization with Grafana. What you need to remember from this presentation is that all GP4L components that I mentioned, so the testbeds, the labs, or the playground on top, and the community, are free for use by anyone who would like to do any type of research inside GP4L and can be used independently. So it is up to you to get inspired and think of a use case, and then to get in touch with us and let us help you on your research journey. All components will be supported and fully maintained by Work Package 6 Task 2 during the whole duration of the GÉANT number 5 phase 2 project. So that means in the next 3 years. So just to finish here, as I mentioned before, I hope you'll get inspired with this Infoshare and get an idea of how you would like to use the GP4L testbed. Once you have the idea in mind, please just contact us and we will help you start using GP4L to get answers to your questions. With this, I would like to thank you and remind you again to take a look at the documentation. And of course, this is the mailing list where you can contact us with any question or any idea you might have. With this, I will now give the floor to Frédéric to tell you a little bit more details about the testbed itself and how you can actually use it and what you can use it for.
Thank you, Sonja, for your introduction. In this section, I will present you some details about GP4L testbed, which is actually describe the goal is to describe you a bit how it was created from ground up. The interesting thing is that it was not created as it was not targeted to become a global lab services from the ground up. The idea was that when we started the activity, the goal was really to simply create a development environment to validate our routing software we were developing back in 2019, called the RAR platform. That is still this work is still ongoing. So we decided to deploy a set of nodes just in Europe. You see the red circle, and we don't know why, or it was totally unexpected. But in the end, we had a lot of positive welcome and feedback from the research community wanting to connect their infrastructure, some nodes that they have to this small set of nodes in Europe. So then this is the start of what we called from the RAR project, we started to have something called GP4L, which initially stands for GÉANT P4 Lab. Why GÉANT? Simply because the testbed was the core of the testbed was simply composed by GÉANT nodes. And as you know, probably already know, the P4 language is a domain-specific language that is used to program specific hardware. And the nodes we deployed were able to be programmed as using this dataplane programming language. So in the early stage, we had this wonderful environment called GÉANT P4 Lab, and then we started to see people in Europe wanting to connect their own P4 switch. So we started to see people a new connection. We witnessed new connection from France, from Switzerland, from Ireland, and then the very interesting thing is that back in 2021, we simply started to connect other nodes, other programmable nodes from the continent, from other continents such as the US. And in that context, we managed to connect some nodes in Caltech, Miami, University of Tennessee, and we also reached Latin America, that where we deployed, where we had the chance to meet people from UFUS, who invented the polka paradigm and wanting to do some experiment. So in this context, the GÉANT P4 Lab, the GP4L acronym, was not European anymore, and this is why we started to have this GP4 with a GP4L acronym, meaning Global P4 Lab, till then, till now. We manage what is important to oops. What is important to see is that now we have reached worldwide coverage that is running a set of different programmable nodes, and these nodes are composed by programmable nodes that can be that can use the P4 language. In that context, we mostly have deployed barefoot wedge model P4 switch that has been now acquired by Intel, but we were thinking somehow that it was overkill to deploy a node with 32 ports with a 100 gig, and we also work on deploying smaller node running the DPDK stack. This programmable data plane were controlled by mostly two control plane that Marcos will present you afterwards. One of one of the first control plane that is open source is Sonic, which has been open source by Microsoft, running mostly in the cloud environment. And the other one is a community control plane developed in Hungary since 2010 by one of our partners from Kifu, that is called FreeRouter. While Sonic is more geared toward answering data center use case, FreeRouter is mostly adequate. It's a perfect fit to address most unrun use cases such as MPLS network deployment across the worldwide environment. And what you are seeing now in the screen is what has been presented during the last Supercomputing 24, where this whole domain is running this set of nodes, running P4 switch on Sonic and FreeRouter in an interworking. They are both interworking basically and are running a worldwide IGP, which is it's a bit technical, but it's an OSPF domain using segment routing. So this is quite innovative because on top of this infrastructure, lab infrastructure, you are able to elaborate new demos. And this is using this infrastructure. This is via this infrastructure that the UFirst researcher validated the Polka algorithm, which is essentially an entryless forwarding paradigm at the node level, which means that there is no entry on the nodes that are programmed beforehand in order to forward the packet. It's a magic algorithm that I invite you to and I invite you to read the paper. So I would like to really hammer what Sonja presented during this introduction, which is really important in a sense that it represents really how you need to understand regarding the P4, the global P4 lab. This is one of the really key takeaways. It's simply a set of network programmable node that is deployed worldwide using the existing research infrastructure. Most of them are deployed in a research institution, but you have you have GÉANT core nodes that you can reserve and use, which is in order to validate your own idea or your own experiment related to network itself or around or if you want to validate technology around the network ecosystem. When I meant network-related usage is, for example, we validated with Juniper, we validated a multicast mechanism that is called automatic multicast tunneling that basically provide a gateway to non-unicast network to receive multicast traffic. So this is something that is in still a draft state. But it was really interesting to see that the multicast domain deployed in GP4L was able to serve multicast traffic using AMT from Juniper. We also had the possibility to deploy to develop and deploy a FreeRouter IMT, and all was working perfectly. So this is an example of network related usage. We have also subsequently, I will show you some another work that is related to technology around the networking ecosystem, which is how to create a weather map based on netbox and a visualization plugin. Thank you. Now I will give the floor back to Sonja.
That by now people will be interested in how they can use the testbed, so I can give you the information on that and tell you how you can actually use the testbed in order to run an experiment, do research, whatever your heart desires, right? So This presentation is really like a user guide, a step-by-step short user manual procedure, whatever you want to call it, on how you can get access to the GP4L testbed. When I say GP4L testbed, I mean the devices, the P4 devices that sit behind the GP4L playground that you can actually access using NMAS. So let's see what are the steps you need to do in order to get access. Just to repeat one more time, so who can use the GP4L testbed? Any interested party from the research and educational community can request a reservation of some of the devices or all of the available devices in the testbed. Right now, the system allows you to see the reservations and availability only by the GÉANT GP4L nodes, so the nodes that we are managing. For the rest of them, you cannot see their availability, but there is an opportunity in the reservation system to declare your interest in using the other nodes, which are managed by different partners, and then we can get in touch with the partners and see if you will be able to use these nodes as well. So what we are showing here is mainly for the GÉANT GP4L devices, the one that we are managing. In order to get access to the GP4L devices in the testbed, you need, first of all, a VPN connection, right? Once you get the VPN profile from us, you install it and you get up and running a VPN connection, then all you need to do is get an SSH access to a Bastion machine, because all of the devices are behind this Bastion machine. So what you do is you SSH to the Bastion. Once you get connected to the Bastion, then you can connect to any other of the devices which are behind the Bastion. So basically, this presentation is how you can get the VPN profile and how do you get the SSH access to the Bastion. Because in order to get the SSH access to the Bastion, you need to make a reservation request and get an approval from us for this reservation request. Why are we doing it like this? This is just to first have an idea of who is using the GP4L testbed and for what, and to create something like a fair use ground, right? So we are trying to implement the so-called fair use policies for the GP4L testbed so that everybody that is interested in using it can use the testbed fairly, right? So that nobody can monopolize the use of the testbed. That's why in order to get access, you need to create a request. We review the request manually. If we need more information, we are going to request it from you in order to explain why do you need so much time or why do you need so many of the devices and so on. Once you get approval, you will get access to the testbed environment. The current settings of the reservation system are such that the minimum amount of time for a reservation is 1 hour, which is quite small. The maximum reservation time is set to 90 days, so 3 months, just to check with you. If you need it for more, then you can just create a new reservation for the next period of 3 months, and it's fine. So there is no problem with that. This is just to have checkpoints to make sure that the testbed is used and it's not just staying empty because you actually have something else to do. So what are the steps? The first step is to request a VPN profile. In order to obtain the VPN profile, you just need to send an email to our mailing list, which is GP4L admin and lists GÉANT.org. Inside the email, you need to tell us who you are, what is the institution, where you come from, why would you like to use and get access to GP4L. Once we get this email, we will process your request, create a VPN profile for you, send it to you, check with you if everything works, and guide you through the rest of the process, which also includes creating the NMAS profile so that you have access to the GP4L playground, and testing your access to the reservation system in order to ensure that you are able to create reservations. When you would like to use the testbed itself, you need to go to the reservation system. So you connect to the VPN. You go to the link that is provided here, book gp4l.nmas.eu. And then if this is your first time, you need to create user on the system. So you need to click on register. On this screenshot, you see it here, first time user, register. When you click on register, you need to provide the basic information about you. So create a username, the email to which this username is going to be connected, define a password, your name, the organization where you come from, the position at that organization, and very, very important, the field which is called Bastion Info. This field is the place where you need to put your SSH public key that will be used in order to provide you with access to the Bastion machine. So don't forget in Bastion Info to put your SSH public key. If you forget in this step, you can do it later on. Don't worry, it's not that big deal, but you need to have it there so that your reservation works. The next thing, once you register, you get the view of your dashboard. In the part of my account, my preferences, you should set up your notification preferences. We recommend here that you choose to get an email when a pending reservation is approved. In this way, when you request a reservation, you just click request, you can log out of the system. You don't need to go and check every day if your reservation is approved. Once we process the reservation and we approve the reservation, you will simply get an email notification that it has been approved, and that's it. So you don't need to manually go and check for the approval. So that's why we added this step in here. Now you're really ready to make reservations. This is the dashboard view, the main view of the booking system. Once you log into the booking system, you can see here and store upcoming reservations that you have made in case you have them. And you can also see what is the current resource availability of the different devices that you can reserve. You can see the 6 devices that belong to GÉANT. At the moment when I was taking these screenshots, there are no upcoming reservations in the next 30 days for any of the devices. That's why you have this reserve green button where you can click on any of these devices and start the reservation process. Pay attention to this other resource, which is under the unavailable all day and will become available on Saturday, the 31st of May. This is the resource that you use in order to tell us that besides the GÉANT devices, you would also like to try and use devices from other partners. This device will always be unavailable because someone also wants to do the same thing, but it doesn't, if it is already reserved, it doesn't mean that you cannot reserve it as well. You see, it's not available, but you can click on the reserve button because for this device, we allow it to be reserved in concurrent sessions. So don't worry about that. Okay, let's say you choose a device. In the screenshot I have here, I have chosen 3 devices. I started by clicking reserve on Amsterdam. So here I clicked on reserve next to Amsterdam 0001. Once you click on reserve, you get a screen like this, a screen for new reservation, where you need to enter a bit of information about your reservation. The bits that are mandatory are when the reservation is going to start, when the reservation is going to end, do you wish to make this repeated reservation or not? What are the resources that you would like to use? What is the title of the reservation? And what is the description of the reservation? So you need to provide this information. In the beginning, when you just click on Amsterdam, under resources, it will only show Amsterdam, but if you would like to reserve multiple devices at the same time in one reservation, all you have to do is click on the plus button next to resources, and then you can choose from the list of available devices. This is how it looks like. So when you click on the plus button, you see the list of all of the resources that are available. In this example that you see here, for an example, Amsterdam, Frankfurt, and Poznan are not available in the time that you set for beginning and end of reservation. So that's why they are red and they are crossed. You can choose to add a different devices, such as the one in Budapest or in Paris or in Prague or the other type of device. The test device that you see in the bottom is for testing purposes only, and you shouldn't be using it for any reservations. So using this view, you can actually see what are the devices that are available in the time span of your reservation and make accordingly the request for reservations. Once you have a nice title and a short description, make sure in the description you tell us what you will be doing, what would you like to do, and so on, because this is the field that we will analyze together with the resources. You just click on create and the reservation will be created. You will get this message where it says your reservation is successfully created. However, one or more of the resources require approval before usage, so that's why the current status of your reservation will be pending until it is approved. And in the dashboard, you will see your new reservation under upcoming reservations, but it will be orange because it is pending approval. At this point, the GP4L admin will get an email notification saying a new reservation has been created in the system. Please review the reservation so that we can see if it can be approved. Once we review the reservation and we say, yes, okay, no problem, you can use the GP4L testbed for these devices for this amount of time, your request will be approved. You will know that your request has been approved because you will get an email notification like the one you see on the right-hand side, reservation created for Amsterdam. Well, the title is not really very informative, but unfortunately is a system title and we cannot change it. But you will see the details of the reservation that has been approved in the body of the message. And if you log in on the reservation system, you will now see your upcoming reservation, but it's no longer orange, it's white because it has been approved. Everything is great. If you don't touch anything, you don't do anything, then at the exact moment of the beginning of the reservation, the system will automatically send your SSH public key that you entered in the Bastion info field during registration to the Bastion machine. And this key will be active until the end time of reservation. So you don't really need to do anything. You just get notification approved. That's great. The next step is to basically show up at the beginning of your reservation time. Everything else will be done automatically by the system, and Roman will tell you how it is done in the background. If you need to make some changes, okay, maybe you forgot something, maybe you want a different, to use a different device or whatever, you can still do it. So even after your reservation is approved or authorized, you can still make a change to it. If you make a change to the reservation, you need to go through the authorization process again. So it will shift back to pending. We will get a notification, we will review, and then we will approve. You will get a notification that it is approved. If in the meantime, your SSH key has changed, you just go to the profile of the reservation system, put the new value inside the Bastion field, and it's fine. So the correct key will be sent to the Bastion at the beginning of the reservation. If, because of some reasons, the resource that you have selected for your reservation becomes unavailable, you will get a notification saying the resource has become unavailable. You are then free to choose if you want to make a change to the reservation, so choose another resource instead of that one, or leave it as it is, knowing that that resource is unavailable, but the others can still be used. Basically, these are the possible things that might happen. If the resource becomes unavailable, you get notification via email. So you will get this email, for an example, where the availability of the Amsterdam node has changed. You can follow the link, log into Libre Booking to make a change of the reservation if you want to do it. Of course, when the resource becomes available again, you will get a new notification. So if you do nothing, it has become unavailable, then it has become available after a while because we were doing some upgrades or maybe something went wrong, we fixed it, then you will be notified again that now it's okay and you can use it. As I mentioned before, if you would like to try to use a node that actually belongs to a partner of the global GP4L testbed, then you need to let us know by creating a reservation using the other resource. And with this, you actually let us know, saying, okay, I want to use other devices. In this case, when you do the reservation in description, tell us what are the devices, the other devices you would like to use. Then we can get in touch with the partners that are hosting these devices and see if we can provide you with access to these devices to create a large-scale testbed. When the reservation time arrives, so at start of the reservation, all you have to do is activate your VPN, go to the reservation system, click check in, the orange button, and then you just go to the Bastion, USSH. Of course, the SSH key is the one that you provided in the reservation system, and then you have access to the GP4L devices. Please note that the system expects you to check in within the first 10 minutes of the reservation. Otherwise, it will auto-delete the reservation just to try to implement this fair use policy, right? Because sometimes someone might reserve something and then decide they would not like to use it actually when the time comes. Once you click check in, you get this message here, you are checked in. That's it. You don't need to do anything else. You're ready to start with your experiment. Also, because of the fair use policy, in case you no longer need the testbed, but you have reserved it for one more week or for one more month or whatever, in order to release the resources for use by others, please click on check out. So go to the reservation system and click check out. When you click check out, what you actually do is you release the resources, make them available for others to reserve them and to do their own experiments. Of course, during this process or any step after this process, while you're using the GP4L devices, if you experience any problems, if you need any help, if you need any consultations, if you need anything, all you have to do is just contact us at the same email address and we'll respond as soon as possible. We're always here to help you. I hope that with this, it has become a little bit more clear on how you can use the testbed and how you can create a reservation. This step-by-step instruction is also available in the text format on the documentation of the GP4L pages. Now, I think it's time to actually talk about different types of uses of GP4L, different types of use cases. And the first use case that we have is Roman, that is going to talk to us about how GP4L works in the background and how this has been its inspiration for other work that is related to GP4L. And this is the service provisioning pilot that we were working on.
So I will describe in my presentation the resource management and reservation orchestration implementation in GP4L that we have implemented in the project. So Sonja already described you the GP4L in general. So I will not repeat this, but I will focus only on labs pillar. So this pillar is about the initiatives around GP4L infrastructure. So there are efforts to design, to implement, and to test network management solutions. So when we started the work on orchestration and automation in GP4L, we had a discussion with Frédéric on how he manages the GP4L network, how the processes looked like, and which of them are the most important to automate. So so the goal was to move from a manual approach to orchestration and automation. So we identified workflows. We found their characteristics, some conditions, some functionalities, etc. And we wrote down their graphical representation to be able, in the next phase, easily implement them. So we also said that we want to use the NMAS system, which is a virtual environment to run network management and monitoring tools. We also said that in our workflows, we want to use open source software, only open source, with flexible and complete APIs. And also important was to implement the solutions not only for GP4L. We want to make it reusable by other network operators. So we identified three main network operations and their workflows. So first, automated resource management. Next, automated resource reservation for experiments. And this was presented, the portal, how it's implemented and used. It was presented by Sonja in the previous presentation. And the third use case, network operation, is service provisioning that we implemented in GP4L team. Okay, let's start with the first use case, automated resource management. So the maintenance of 40-ish GP4L nodes is not an easy task, especially if we have to use multiple monitoring and management tools. That is why the implementation of workflow to manage the node, how we manage the node. We can add a new node to the infrastructure. We can delete the node, remove the node from the infrastructure, or we can update the node. So the implementation of this management was the first choice for the implementation. So instead of configuring tools separately, the user only updates the information in the source of truth, in the netbox. And you can see this component in the picture on this slide. In general, the use case is composed of four main components. The source of truth, the orchestrator. Here we implemented this component with the use of Camunda, and two other components, one for monitoring, uptime QMA, and the second one for configuration backup, oxidized with GitLab. So a user can update the information about resources in netbox, in source of truth, and the corresponding process in the orchestrator, in this case Camunda, is activated, and other tools are automatically informed about the update, and needed actions are done there as well. So if we add a new resource in netbox in the GP4L infrastructure, then this information is automatically transferred to uptime QMA and oxidized by the workflow. So the next slide, you can see the screenshot. On the left, there is a netbox window, on the right, uptime QMA window. So in netbox, now we can see 5 nodes. 4 of them have IP addresses, and we've got monitoring configured for them in uptime QMA. For the 5th node, we don't have monitoring because interface is still missing. The IP address is missing. So take a look that when I when the user provides the IP address in the netbox for this interface, automatically this information will be forwarded to Uptime QMA, and monitoring will start for this node. And at the same time, Oxidized will be updated, and configuration of this node will be stored as well. And similar actions will be done when a user remove the node or change the IP address. So such information will be immediately and automatically transferred to other tools in this use case. Okay, let's move on to just one additional information that you can see a longer demo of this use case on YouTube. And this demo also, this video also includes presentation of next use case, reservation use case. That was also described by Sonja in the previous presentation from the perspective of a user. So this use case has been implemented for researchers. I repeat the information about this use case again after Sonja's presentation. So this is for researchers who want to run their experiments on GP4L infrastructure. So users, as you've seen, via portal can reserve the resources, ask to access them, get the approval from the admin, and then at the start time of the reservation, the reserved resources are available. So you can also see that we had some requirements in this use case when we started implementation. And this here you can also see the components. We have more comparing to the previous one. So again, we have source of truth. We still use netbox here. We have two orchestrators, Camunda, to synchronize information between netbox and other components. We have Airflow orchestrator. We've got Libre booking for reservation presented by Sonja, and we have Bastion machine to give direct access to reserved GP4L resources. So for the reservation actions, we use Libre booking. This tool has a list of resources which is synchronized with netbox. If we add new or remove a resource in netbox, this information is synchronized with Libre booking. When a reservation is accepted, then the process in Apache Airflow is executed, and at the start time, the SSH public key of a user is sent to the Bastion Ubuntu machine. From the Bastion, all reserved GP4L resources are accessible. When the end time of reservation is reached, then the key is removed. And from this moment, a user doesn't have access to the resources, to the switches of GP4L infrastructure. More information, detailed information about this use case and the previous one, you can also find on our GP4L website. Okay, and now the third use case, the third implementation. It's a orchestrated service provisioning. So we deployed at the moment the pilot in Pioneer, Polish network. You can see the components of this pilot. So again, we use Airflow to implement workflows in Python. We also use MAT as a source of truth instead of netbox. We decided to use MAT in this case because we needed a source of truth with much more flexible resource and service modeling. We also use Ansible with Jinja template and GÉANT LSO application to run Ansible playbooks remotely. It's still a pilot phase, so we don't run the implementation in the production environment, production infrastructure. It's still tested in the virtual network based on created using Container Lab. And the implementation of workflows, sources are stored in Git repo, and it's available to all who are interested to take a look how it's implemented. Okay, and the first service, network service that we implemented for provisioning, it's a layer 2 circuit service. So here on the slide, you can see a simple picture of the components again, and the communication between them. So simply saying a user provides input information to the workflow in Airflow, provides DNs, the information about the routers or switches and their physical interfaces. Workflow communicates with MAT, with the source of truth, they exchange data, and then workflow executes Ansible playbooks via LSO application and the Container Lab in the virtual representation of network. So when configuration is correct, then configuration is uploaded to the production environment, to the production network. As I said, we still have a pilot in Pioneer, but it is planned to have production deployment in Pioneer this year. Full demo of this use case you can see on YouTube. There is a nice video about it, presenting all the tools, presenting, for example, graphical interface of Airflow to monitor the running workflows. You can also see their graphical interface of MAT and how the information changes in MAT during the workflow. Okay, lesson learned from the implementation of use cases, those 3 use cases that I showed to you. So some headaches. We found out that documentation of the open source tools that we use in our workflows is not perfect. Sometimes the information, technical information was missing. So at the end, we had to take a look at the code to find how to configure some things or how to use specific functionalities. We also found some bugs in those tools. Data integrity also is sometimes a challenge because in our workflows we use multiple tools and they describe resources or some objects in different ways, and we need to sometimes synchronize information between tools, and yeah, data integrity then is a challenge. Backward compatibility. We had a situation when after the upgrade of a tool, the workflow didn't work correctly because there were some small changes. Sometimes there were some small changes in APIs or in the implementation of functionalities. So we had to update the workflow to execute correctly new version of tools that were called by the workflow. But at the end, I have to emphasize that the workflows are very flexible to implement network services because it's maybe not very easy, but it's quite comfortable to add new functionalities in the workflow to replace some implementation in the workflow. For example, in provisioning implementation, service provisioning implementation that we have in the pilot in Pioneer, we use MAT, source of truth. But I think that if there was a strategical decision to start using netbox for some reasons, it's possible. It should be quite easy to replace MAT with netbox or other tools, right? So workflows are very convenient to reorganize network operations, enrich them, improve them, etc. Okay, thank you very much for this short description of use cases that we implemented in GP4L group. As I said, more information can be found on our website, GP4L website. Also about MAT, you can find information on its website. MAT is the application implemented by the project, actively developed at the moment. And if you have any questions, any comments, you can contact us via email, and you see the address here. So thank you very much for the time.
Now I will present you a use case, but that is not directly network related. So we won't invent any new protocol. We won't try to verify if a specific packet marking is done correctly. In that case, we will just pursue and complete the work that Roman presented during the last 20 minutes, which is when you want to orchestrate and automate something in your network, you obviously need to have a perfect visualization tool. So basically, what we aim to do in this use case is to give the possibility to user to get a visualization, to get a view on their network map, but without any effort, in a sense that all the effort, all the tedious work should be done upstream, but once, and you should not repeat all this work when you want to get visualization. So in this case, we will use netbox as a source of truth and show and use Grafana visualization plugin that is called mapgl. We will see also different type of plugin, but this is for further discussion. If you are interested in using the other plugin, we can obviously exchange, and we can engage some discussion offline. So real brief agenda. The first point is to hammer the core message, which is, okay, what do we want? What do we want to achieve? And what are your benefits on this exercise, in this exercise? The first thing that we will present, which is the basic building block of everything, which is the source of truth. Which is this is a word that Roman mentioned a lot before, but here I'm completing this concept with the word inventory. Okay, so when you have this inventory, you need to somehow share this source of information to an external system that will basically feed your tools. So in this case, we need to an interface able to export network information from the source of truth all the way to the visualization tools. Then when you have that, you need to generate effectively this visualization. And from that, in that context, we will graph an weathermap plugins. And I put an S because you don't have much choice, but you have basically three alternatives when you want to achieve that. We will go through all these alternatives later. So this is the goal. Okay, we want to have something that is that would represent your network, and in this case, this is GP4L. The cool thing is that, as I said before, all these node is rendered automatically, which means that tomorrow Sonja will deploy a new P4 switch in Africa, for example. I will just wake up and this map will be updated with a new dot in Africa with the link between connecting this dot to a node in the over node in GP4L, which is, for example, the case in Tokyo, where we deployed an unexpected P4 node with a transatlantic. We're going through the transatlantic link all the way to Amsterdam. So this is the idea. If you look at this, you have a lot of details that are expressed in this situation. You can see that you have links that are more thick than the others, and this is information. This is an information where, for example, the thicker links are 100 gig links, while the smaller link are 10 gig links. So all of this is included into the source of truth. So you can render this automatically. One thing that is also super important, maybe not in this picture, is that you can see different colors. On both, when you have a link, you have two colors. Each colors actually can render the actual current link load, which is the number of packets, the traffic rate going from one node to the other and vice versa. All of this can be done automatically, and this is why we are calling this a network weather map, which is something that changed over time during the quantity of traffic that your network is conveying between two nodes at some point in time. Okay, so now let's tackle the first thing which is the inventory source of truth. When you are talking about a network source of truth, you don't have much choice. Basically, you have the usual suspect that the first one is one of the most popular is netbox, which is the first, I would say, source of truth oriented toward data center management. Based on that observation, you had a fork of netbox that at some point in time, some people thought that netbox was not network aware, and should be. There was a fork of netbox where people decided to give a different orientation of regarding the type of resources that has to be managed. Not only data center, but also network equipment in the one environment or map. This is just for reference, but you have also a DSIM tool that is called Device 42 that we actually in France we used to use. I'm just putting it for reference. But all of these three can be considered as a resources inventory. When I mean resource inventory, it's really related to material hardware, something that is really physical, and opposed to what I would call service inventory. And this is where a very good tool developed by PSNC and used by Pioneer, presented by Roman, it comes into play. And this tool is called MAT, because MAT can give you the service definition in a very flexible way. Obviously, with MAT, you can also define resources. And in this case, PSNC decided to use MAT for both resources and services. So the resources, for example, is a router A connected to router B using this dark fiber, using amplifier on every 15 kilometers, for example. But service inventory is I'm deploying on top of this infrastructure, I'm deploying a layer 2 services or layer 3 VPN. So the user can have internet via this link, for example. This is a service. So just to give you a bit of background about what is the real difference in GP4L, what is a service, what is a resource, and how we can treat this. Why I put netbox in the service inventory square? It's simply because recently people realized that netbox could be extended to manage other things that only pure data center, and we are starting to see new features that were originally only on Notobot. But now in netbox, now you can have in a recent version of netbox, you have IPAM, you have internet registry, other things that can help you manage the service provider network. So these things are changing, and that's also one of the reasons why we in GP4L we decided to use netbox, simply because it is complementary to MAT, and it's good to have an alternative so we can share our experience with user. So in this case, now that we have our source of truth, we need to find a way to export this data to other systems. So this is where a project from GitHub, NetReplica NRX, comes into play. We spent some time with the maintainer of this project, and we co-developed things together. Did some suggestion, and the cool thing with NRX is that you are able to fetch data from the source of truth, and then you have the possibility to export in different formats. So one of the formats is Grafana for visualization, but it's another subject. But if you're interested, you can also fetch the data from the source of truth and create what we call a digital twin, a replica of your current network using a network emulator called Container Lab. And also you can have basic diagram. You can use a favorite diagramming tool, which is in this case it's called D2. But the most important things here is that you can use an interface that is called NRX that has the possibility to define various format output with different criteria. We will see that later. So on the left, the square describe a source of truth. So something that you initiate on your documentation. You said, oh, this is the reality. But on the right, what you can do is to deploy some network feature. There is a specific feature called BGPLS that gives you the possibility to verify that what is effectively deployed in your network is compliant with what you expect in your source of truth. So it's a bit different in this case, but here the idea is that the information of what is deployed is in the network, you fetch this data using a mechanism to your favorite SDN controller. So the SDN controller is simply a host receiving the data, and this data can be used to correlate what is deployed compared to what is expected in the source of truth. So this is the interface. Sorry. So in terms of workflow, it's quite easy. Then you have the source of truth. But what is really cool with NRX is that you have the possibility to have multi-tenant. When I say multi-tenant, it's multi-organization. So in the source of truth, you can have different organization that has different network. And in this network, you can also have another way to identify sub-network in this network. Let me give you an example. We have, for example, we have the core network in the RENATER backbone, and in this all of this network can be included into a source of truth. But we can have also the regional network. Some of them are managed by RENATER, so we can have a different role, netbox role. We can say, for example, the core backbone, and then a network in Normandy or in Paris that is managed by RENATER, but it's a different role, but it's a different network, sometimes different AS or something. So this can be done at the source of truth level. The second thing, the second mechanism that you can use in order to discriminate in a subtle way the networks inside your backbone is the possibility to use what we call network tags. Just an example, we have one tenant in the GP4L source of truth, which is the GP4 lab, the global P4 lab. In this global P4 lab, we have various demos that we can run on during some conference, Supercomputing 22, 23, 24. We run various experiments. What we can do is to expose and identify in the source of truth all these demos using specific tags, for example, SciTag demo, Polka demo, and then the tools downstream can identify what to do with the information they have. So the data export can be done on a per role basis, on a per tag basis, and output different data model. So talking about virtualization is the different output. So here, when you want to represent a network, you have mainly three alternatives. You don't have much choice. The first is to use the inherent native Grafana GeoMap panel, which gives you this type of view. You can see that you can have the different thickness. You can have also the link, you can have the mid-link, but what you can see is that the line are straight. You cannot have curve. So this is one of the limitations, but also this can be used to render maybe 100 nodes, but not that much more. Okay, this is the ESNet network map panel, who is developed by our colleagues and partners from the US. This one is also available and can be used to represent your network, and is really is meaningful for network operators. So if you want to reuse this, but in this case, you see that you have two links between nodes. So you have the transmit and the receive. While here you have only one link and the midpoint. You see, so this is quite different. And you have a last one that I would say that is the new kid on the block of the visualization tool, which is mapgl. Mapgl is basically another network visualization plugin in Grafana available. You have one paying version and one open source version. The cool thing is that we have established very good relation with the lead developer, who and all what you are seeing is currently our suggestion from our development effort. So all this thing. One of the particularity of this is that you, apart from the thickness, you have the possibility to represent each node with a different SVG icon to represent the group, and the group you have the possibility also to render different color based on for the nodes based on specific data source. So all of this can come from your favorite time series database that you are currently using. You should not drop your tool. We should just reuse it and connect it to this map. And let me show you a demo of this. You are still seeing the screen. Oh,
Yes.
this is the global P4 lab here. What is why one of the strengths of this panel is that it is using a 3D hardware renderer using the core is rewritten in Rust, and it can be used to render around 7,000 nodes in your laptop, which is incredible. It's not obvious like that, but it's a 3D map. Okay. You can reduce it, and then the clustering occur. You have clustering. What we have developed in the context of the GP4L is, for example, let's go to Geneva, and we can click on the link load between some nodes. Okay, the nodes is Geneva connected to Frankfurt, and we have not that much, obviously, because we are not sending a lot of traffic. But here you can see that this map is directly coupled with the time series database. And we have a very interesting link here where we quit the geographic view, but we are going logically here, where I want to zoom inside the Geneva nodes, where we have deployed a set of Tofino 2 switch with 400 gig links and other switch, hybrid switch that are capable to do things. And this is where it's really interesting, because what we have done here, it's something that you can benefit instantly as soon as you have your source of truth. Once you have your source of truth, you can benefit from all of this in a very, very short amount of time. So this is one of the ideas. You download the dashboard, you put it in your visualization tools, you connect it to your source of truth, and then you have this thing that is living. So what is important to understand is that when you couple this with what Roman has done, as presented, you have something that can be updated every day. Every time there is a change, you have something new, that without you doing only one thing, working on the source of truth. So this is the power of this. If this visualization does not suit you, or you don't want to use mapgl for some reason, because you don't like curve or whatever, you can still use GeoMap. So this is the same. This is the strict exact same information coming from the source of truth, but that is rendered differently. We can use also ESNet GeoMap panel if you don't want to have fancy curve. And something that is really meaningful for a network operator, you can use this. You see that it is the same network. It's the Pioneer network. And we have also the Pioneer network that can be rendered using the same information differently with a different plugin, which is interesting. Again, I don't want to brag about that, but it's not that much node. But imagine if you have more nodes and the possibility to zoom and the possibility to change the icon. This is really great. And very good exercise, just to give an introduction to Marcos, because he will be the next speaker. This is the RNP network that we showed during SC24. Just to verify my theory, I spent 5 minutes in just getting the information from Marco's netbox source of truth. And in 5 minutes, we were able to have this beautiful view of the RNP network. That is insanely great because I wasn't thinking what was the capillarity beforehand, but now now I know it's not a small network. And that's pretty much it. That's what I wanted to share with you.
Thank you very much, Sonja and everyone. So I'm here to present some of the developments that I've been participating with GP4L. Mainly, I'm a community collaborator. I'm representing collaborations from RNP and also in partnership with many other groups. So basically, I've tried to engage GP4L other initiatives, trying to integrate with different testbeds like Fabric, also using dynamic circuits from Notable and Sense, and also integrating use cases from data-intensive sciences. So I'm coming and going and trying to see how things can correlate. And mainly, I think that GP4L has the same vision that what I'm trying to work in RNP and also on the global community, which is how we can increase the rate of evolution of our research and education networks. And as always, we are trying to look for safe places that work just as the production, but in a more safe and sandbox scenarios. And GP4L is exactly that. So this is the reason why we have been supporting and collaborating. And mainly, there are a lot of different services that we already have inside our national networks or in our own networks, but they are not as present on the overall multi-domain and end-to-end scenarios. So trying to work, integrate, try to get a heterogeneous environment, different APIs, different vendors, and different paradigms is important for us to push the boundary of what is already possible and also to educate and support those that are still trying to learn the existing paradigms and haven't adopted. And a lot of software needs to be developed and be mature so that it can be pushed into production. So the way to do that, basically, what I'm working in partnership with GP4L is building programmable platforms that can be persistent and be able to work as pre-production scenarios. So there's still labs, but they need to replicate the services and functions of production environments and leveraging the industry standards, industry vendors, and also our R&E and open ecosystems. Sorry. Yeah. So this is what you have been seeing in many slides, but this is the current GP4L network. And just saying that we have a core devices based on Tofino running free router, but we are also pushing for other type of networks, mainly using programmable smart NICs. So this is something that the industry is bringing in. It's more, I would say, light and more flexible platforms, of course, with less ports and less capacity, but there are very good trade-offs for prototyping new infrastructure and new paradigms. And also we have DPDK as a lightweight approach for standard NICs to be able to participate, not as much performance and capacity, but as a way to have more partners around the world trying to push for a similar capacity and workloads. And my work today will focus on this left side and trying to run different stacks to try to at least replicate the performance of hardware switches on software data planes on servers and NICs, so that we can prototype new control plane options, new data plane protocols, and trying to push the boundaries of what's possible. So basically try to augment this core network based on free router with other type of networking OSs so that we can have heterogeneous environments for more complex and different experimentations. So just a context of what we are looking for. So the Tofino hardware is our best hardware today. We don't have anything to complain other than it won't be continued by a successor directly by the same vendors. And the industry have been pushing, I would say, software, smart NICs, which are sometimes called IPUs and DPUs, and mainly for Intel and AMD, they are taking the flag from P4 on. But we are looking for next generation ASICs so that we can have that data center or like a light router approach with a lot of ports and trying to build new labs and evolve the ecosystem for more than 5 years. Until there, I think Tofino will be much competent on 400G networks and also the existing capabilities of the programmable hardware. But there are already some successors being expected in the near future. And of course, recently the Tofino compiler and the software development environment has been open source, which have sparked a lot of innovation from the community. But until have a new hardware platforms, we are also focusing on different software stacks. So mainly our main platform today, most of our GP4L nodes are composed of FreeRouter and Tofino, which is great, or basic architecture. We're trying to expand that to other stacks like Sonic, Pins, and Dash, which has been a lot of community effort, a lot of different hardware platforms. And also we don't have to support that as a community. We are basically giving small contributions and getting a lot back. And thirdly, we are now starting to work with VPP and what I'll present today, which is this software data plane. And also it can be integrated with P4 accelerated pipelines in software, and also a Linux control plane, which is a very interesting feature I'll show in a minute. And the thing here is try to broaden the spectrum of devices that we can create digital twins or even line rate software routers and try to integrate at some points in the architecture. Okay, so VPP basically is a software data path that is accelerated using CPU and also some features of the network cards. It's meant for data centers or for servers, but also supports a lot of routing and WAN protocols. So just some of the features here. So it's basically line rate for 10 gigs of 64-byte packets and can be line rate for higher packets on higher performance that I will show soon. It has support for multipath using CMP and some other advanced techniques, and also support network programming using segment routing with many options. It's also traffic steering. So it has a lot of embedded features that are very interesting for us. Also support many devices, mainly the PDK as a software acceleration kit, also more native acceleration solutions in Linux like eBPF and XCP. Also supports RDMA, which is a library that exposes some direct memory connection features from the NICs, and also some specific accelerators for specific NICs like Intel and Marvel. Also, it has the Linux control plane, which basically is a solution that it tries to integrate any software that runs on Linux that install features on the Linux networking stack can now install these rules on VPP. And since DVP brings around 10x performance over Linux, now you generate a very fast software approach for any existing control plane. And also VPP is used on many solutions for high performance routing software, mainly Sonic already has this as official backend, iOS, which is fork open source from Viara, which is also a community open source network router, and also some security solutions like Netgate TNSR, and also CalcVPP, which is a plugin for Kubernetes. Just some current state and components of what you're seeing. What I'll be testing or have been tested on supercomputing last year that we present today is the bold part, so VPP, DPDK on both NVIDIA NICs and also DPUs. And we're mostly looking for segment routing to see if I can get line rate performance on 100 gig NX using those. But we can see that overall, we can use different drivers. We can use a lot of different control planes, which is the next step for this year. So mainly on the left, we have some open source approaches like FreeRouter, Holo routing, which is a very prominent Rust-based routing stack that has already model-driven configuration and something that we are keeping an eye on, and also others that I mentioned. But also we will look to see if there's an easy integration path with existing commercial options. Some of those can be run by free, or some you need a contract with the vendors. But it's also interesting to be able to those that have those licenses to be able to run those on the same environment that we are running the open source solutions for fidelity and reality with the existing platforms. On the bottom path, I made also last year some preliminary testing using different drivers, and I could reach the conclusion that DPDK would be the best option for trying to bring library performance. Those tests were run with 9K MTU, 9,000 MTU, which is what I'll be focusing mostly on my tests, but also on next slide, I'll bring some numbers for other type of packages. So this is the first experiment that I did last year on Fabric now and also on NRP. Those are both American, North American test beds that are open for running experiments. And the idea there is to prototype the new generation of software stack that will be integrated with GP4L. And also, I've done some testing on integrating nodes on those infrastructure with existing permanent nodes on the GP4L, and that was presented on Supercomputing 2003. So basically 100 gig interfaces, packet sizes from smallest possible up to biggest possible, also standard 1500 MTU. And we are looking also to some specific size like MSS 4K and 8K. And those are because there are some very interesting tunings for transferring high performance flows that you should use zero copy and line the packets to memory. So those are important numbers for further scenarios. But today is just to bring a different set of scenarios to test on it. Also, we're using a DPDK package generator. Basically, it's a very fast, very low resource consumption package generator that can be very flexible to use on these scenarios. And in this test, we're just doing a back-to-back test. And on Fabric, we are running NFX6, and also on NRP, we're using Bluefield 2 nodes. And you can see that the performance of both on x86, so using the CPUs on the server itself, you have a very good performance when you go above 1500 MTU. And we can see that it's basically line rate for 100 gig on 4K and above. So those will be the size of packages that we're using on further testing around the world. But those are also the common packet sizes for high performance transfers today. And just to comment that for running VPP inside the ARM core of the DPU, so the DPU is basically a smart NIC that has a dedicated programmable chip and also have a system on chip with ARM cores. On those, the performance is not great. We can see that there are some bottlenecks that when you increase the packets above 4K, the performance drops. So probably there are still some things to be fixed either by the vendor or some tuning that are not necessary on x86 platforms. So those things probably should be taking a look in the future and try to maximize the performance and get a more closer to what we would expect on traditional cores. And now this is the second experiment. So now we are trying to look for the encapsulation performance. So not only routing packages with simple layer 3, but also running tunnels, because that's part of the basic technologies for some of the challenges that I presented earlier, like building multi-domain tunnels and circuits. We probably will use on VPNs, we probably use those technologies. So we are trying to compare the performance between VLAN and PLS and SRv6 and see if those can present a similar performance. And as you can see in the result, basically we got persistent performance. All the scenarios is a really great approach. We're running this on software on an existing testbed. So we are creating this platform so that we can experiment now with more complex technologies. And just to comment, so we have now more elements on the topology. On left, we have the packet generator, and then we go through a router node, and then between router 1 and 2, VP 1 and 2, we encapsulate with either option that is presented on the results. And then we send back to the generator to count the performance and provide the statistics. So this is the best scenario that we could expect. Basically, we got the same result that we got without encapsulation with every single option. Remember that VLANs has 4 bytes of overhead, MPLS also, but SRv6, it brings 40 bytes of headers to encapsulate and provide all the logic. So great results so far. And now the future work that we are working on for this year will be try to not run static configuration and protocols in VPP, just provide that, but we integrate with existing control plane options like FFR, Holo, and some vendor options to be able to run dynamic protocols like OSPF, ISIS, BGP, and program that in a more complex scenario and more similar to existing networks. Also, we'll be running some experiments using 100 gig WAN multipath scenarios, and also using traffic engineering to generate optimization between paths and integrate that with the environments. Also, we want to look into hardware accelerator QoS, which is something very important to simulate some capacity on the routers. They are complicated to emulate in line rate on software and on servers today, and also work with P4 DPDK integration. So this is just a proposal that we are still drafting to try to run both VPP and P4 DPDK as different stages on the CPUs, and then you can either have in blue packet or just go to the traditional VPP pipeline or data plane and be able to have other options like going through VPP and then through DPDK to provide enhanced features that can be programmed by a user, and all of that in high performance. Some preliminary results show that VPP can go up to 30 gigs for some experiments. So we're going to see how that will fit, but probably can be parallelized for different users. So then you can bring the deep programmability that we have today on GP4L and other environments to something that can be extended. And on the right, probably something that won't be as high performant, but also trying to see a hybrid approach of using VPP on the ARM cores, on the Bluefield NIC, and also P4 DPDK on the server, just as before. And finally, just to provide about those solutions that we mentioned, next generation. So one is from S-Sites and labs, which called X2 chip, and it's expected to have an open P4 compiler that we provided by Oxide, and also support Sonic as a base platform. So it's something that still is not public, but we are looking as interesting platforms for the future. And also, Cisco has a very interesting hardware that basically be a reference for open hardwares. It supports Sonic, and it advanced APIs for programming the Smart NIC, the DPU side, and it has both a P4 capable ASIC and also P4 capable NIC on the same chassis, but those two are not known to be exposed to a user today. They are used internally to provide advanced features, but the software stack, the development stack is not open for users. So that's something probably we're gonna take a look. And if it not use this device itself, probably there'll be next generations of hardware that will be similar to those. And that's all for now. And thank you very much.